Welcome to Groundwork, a podcast from McLaren Corporation to talk about key material processing topics, from agriculture to mining to material recycling. We'll discuss the best ways to process the raw materials that power the world, because if it's not grown, it's mined. Hi there, my name's David Hunter, Business Line Director for McLaren Aggregate Systems. I head up all of our commercial operations outside North America for aggregates, so sand and gravel, specialist sand, such as frac sand, glass sand, and also the C&D recycling side of things. I've been with McLaren now a little over 4.5 years. Joining me today is my colleague, Corey Jensen, and I'll let Corey do his own intro.
All right. Hi, Corey Jensen. I am the Executive Vice President of McLaren Corporation. I've been working on tailings since around 2006 would be the first project, so almost 20 years now. I oversee the sales, marketing, engineering for the various McLaren companies, and I've spent a lot of that time working specifically on tailings, so it's a subject I'm very passionate about.
Thanks, Corey. Today's topic for the podcast is sustainable solution for tailings management. So suppose for those that are listening, Corey, do you want to explain a little bit more about what aggregate tailings are?
Yeah, so aggregate tailings is generally derived from whatever you're washing, whether it be a limestone, granite, crushed material. You could even throw in there C&D recycled material to get clean products that will bind in concrete or whatever you're going to use them for. You have to use water. Once you introduce water, you end up being able to remove all the material you don't want from the stone or the sand, but that means you end up with what we would call a tailings. Generally, that would be something that's, say, smaller than 400 mesh or 200 mesh, or let's say 60 micron, 36 micron, depending what kind of equipment we're using to create the sand products or recover what we can as a sellable product. You're generally going to be calling the tailings everything that's smaller than that, say 60 micron or 38 micron. And then what do you do with that? That's, really what we're talking about here.
Yeah, well, again, that was going to be my next question. It's you hesitate to say waste, although I suppose traditionally that's been how it's viewed. What kind of challenges do the tailings pose for aggregate producers or sand producers in general?
Yeah, so if you think of any mine site, let's say it's a new site, a greenfield site, maybe there's no existing hole in the ground. The immediate problem is you're washing all this material. Where is all the water and tailings going to go? And that may mean that you need to dig a big hole in the ground or a settling pond, tailings dam, whatever you want to call it. That creates planning issues as well as just management issues, as well as the costs of, digging up that hole in order to put all the tailings into it.
So I suppose it's quite intensive then in terms of the effort that's required and the amount of space required. What historically have our customers been doing to kind of manage the tailings? You're saying they're digging a big hole in the ground. I mean, what are the implications then for the customer?
Yeah, so going back a long time before there was equipment to effectively recycle the water and dewater the solids in the water, the pond or the tailings dam was kind of the only logical solution back then. The challenges that come with that is you need to manage the safety risks of that. So there's some countries, say Brazil or other places, some cities or states where they don't want settling ponds because of the associated risks. There have been failings of tailings dams. So it's a liability on the balance sheet of the company. And, some of the fines or judgments against failures of these tailings dams have been a lot larger than most companies could afford to pay. So you have kind of the safety risks that you're looking at, as well as the mine planning. We've spoken with hundreds of customers around the world that deal with this issue, and a lot of times the challenge is they can't mine close to the tailings dam because they don't want a wall of the dam to fail and collapse the dam. So you have spent a lot of money to permit this mine. Maybe that takes you 10, 15, however many years. You've invested a lot of money to acquire the land, permit the land, and now you're basically isolating a whole section of the mine where you can no longer recover valuable material. Or over time, maybe you have to go retreat the tailings, reprocess the tailings, and that's a huge cost versus processing it right from the get go. So those are, some of the typical issues that they're looking at is how do we get permission to operate the mine? Tailings has become a big focus of a lot of the regulatory agencies around the world. They're much more interested in what are you going to do with the tailings than where are you going to sell your products, because they don't want to be dealing with the issues after the mine closes. So, tailings has really become front and center in the permitting processes.
Yeah, so again, I suppose then that leads us on to, what what are our customers doing now? What do we see in the market today, and what's driving the push for a more sustainable solution?
The next step beyond a big pond was to really, look at accelerating the settling process. So when you have a big pond, acres of land dedicated to settling, the material could settle really slowly, and you could still pull clean water off the top to reuse in your washing process. Some of the challenges with that is you'd still get a lot of evaporation. The more surface area you have dedicated to these ponds, the more evaporation you get. So when water's a challenge, the pond is definitely not always the most efficient way to handle that. So thickeners are what most producers have turned to be able to recover, say, 80-90% of the water immediately and significantly reduce the size of the pond. How a thickener works is it's essentially a large tank. You're pumping the solids and the slurry into the center of the tank into a feed well. That helps distribute the solids as it enters the big tank. As you do that, you inject a polymer into the slurry. The electrical charges on the polymer attach to the electrical charges on the solids. They agglomerate into bigger particles that settle faster. So instead of allowing just the natural speed that the solids would settle, you change the dosing rates within the range of what's possible to achieve a settling rate that essentially allows the solids to settle faster than the water is trying to come up and overflow out the top of the weirs of the thickener. So, that's kind of step one. And I would say most plants these days are doing a thickener right from the very beginning as a first step to improve the water recovery and limit, substantially the size of area needed to dedicate to a settling or pond or a tailings dam.
And I'm guessing then that the order of magnitude of size, if you like, of a thickener tank is considerably smaller than a traditional tailings dam.
Yeah. So, if you look at a typical plant in, say, aggregates or C&D recycling, you could probably say 80% of the thickeners that are used are falling in that 10-meter to 20-meter diameter, or kind of, let's say, 30 to 60-foot diameter
Yeah.
thickener. So, when you're talking about 10 or 20 meters of space versus acres and acres,
Yeah.
it's definitely a much tidier, smaller footprint. And also because of that, you've reduced the evaporation substantially. The water that's recycled, you can put into a tank next to that thickener. You can immediately reuse that in your washing process.
So you can bring the water back in, but given that you have a lot less volume and surface area, does that limit your ability to be able to process material?
So the upfront selection of the thickener is key in order to avoid creating the thickener as a bottleneck to the process. So settling tests can be done to determine using different types of chemicals or a combination of chemicals what is realistic settling rates, and with those settling rates, essentially your goal is to make a thickener big enough that the solids are going to easily settle faster than the water's coming up. So an example that I like to use for this would be if you have, say, a 5 gallon or 20-liter bucket and you put a garden hose into that, you're going to see the water slowly coming up. So you can imagine that if you were trying to settle solids, maybe it's possible. But if you were to put a fire hose into that same bucket, the water's going to be coming up so fast that you're never going to be able to settle the solids. So that's what you need to think of when you're thinking of a thickener, is as you're introducing a certain volume of water into the center of that thickener, that is creating a velocity or a rise rate of water that is coming up. It's a very easy calculation to determine that velocity. And the bigger you make the diameter of the tank, the lower that speed is, and the easier it's going to be to settle your solids. So, a lot of times you'll go to different suppliers and they may quote you a different size thickener. The easy thing to remember is the bigger the diameter is, the lower the rise rate is going to be, and the less chemical you're going to use. At the end, it's basic physics, and a bigger diameter is always going to allow you to process more material.
So you'll process more material and you'll actually probably save on operational cost as well because you're using less chemical to cause the solids to settle out.
Yeah, yeah. I mean, just to give you a simple example, if you go from 10-meter diameter to 12-meter, so your site, you're using up a couple more meters of space, a little bit more steel, so a small upfront cost. That could reduce your rise rate by roughly 45-50%, something like that. If you go back to your geometry classes, pi r squared, you can run the same calculations and basically say, if I take, the radius squared times pi, that's your surface area. As you increase that area and you're putting those cubic meters across those square meters of area, that'll give you your rise rate. And, it's directly proportional to the geometry. So a small investment up front can make your plant use significantly less chemical, just like you're saying there.
Okay. So whenever you've injected polymer into your thickener, your solids have settled. So they settle to the bottom of the thickener. What happens to that material next? Where does it go?
Yeah, it's a great question. So in a pond, it just goes to the bottom, and then eventually you may be trying to muck it out with an excavator or slowly deposit more material and try and consolidate it. With a thickener, you now have contained that slurry in a tank, and you need to be able to have a method for extracting it from the bottom of the tank. So there are several styles of thickeners available. Depending on how steep the angle of the cone is, will determine whether you need a rake to be able to scrape all the solids into the center of that cone, or if you have a steep enough angle of cone, you may be able to get by without a rake. But basically, your goal is you're settling the solids to the bottom of this tank. The longer you're able to keep the solids in the tank, just like a bucket, if you put it in a bucket and you let it settle overnight, it's going to consolidate and keep settling until it reaches its kind of terminal density that it can achieve. The same thing happens in the thickener. The longer you can leave it in the thickener, which is called residence time, the thicker you can achieve as a density, up to a limit of, based on the surface area of the particles and how much chemical you're using.
Well, I guess you get the water on top of it pushing it down as well, which kind of helps
Yeah,
thicken
yeah.
it a bit as well, doesn't it?
Yeah, you have the head pressure from the tank. So generally, the taller the tank is, that can also help achieve a higher density. If you need to achieve a very high density, like a paste, like a toothpaste, you can put pickets attached to the rakes, and the pickets are basically vertical pipes that slowly turn and create areas for the water to escape up out of that thick bed of mud. So you can imagine once it's settled to a certain density thickness, it's hard for the water to get up out of that thick bed. It's almost sealed itself off.
Okay, got
So
you. Yeah.
the pickets can slowly turn and create channels for additional water to get out, which allows it to compress even more. So
Okay.
once you've done that and you're measuring the density somehow with different sensors that we could talk about later, once you've achieved that end goal of your density, then you're extracting it either by gravity using the head pressure of the tank and say a pinch valve, or you're using a pump like a centrifugal pump or a positive displacement pump to then pump that thickened slurry either into a settling pond or into a process like a filter press to do additional dewatering.
Okay. So I'm guessing then that you have this thickened sludge is going to be a heck of a lot less volume required going to a pond, if you like, rather than versus the traditional pond system.
Yeah, so if you think about typical feed to a thickener or a pond, if there's no thickener, you might say have 3, 5, 10% solids in that slurry. Once you go into a thickener in a aggregates or C&D type application, you're probably getting into the 30, 40, maybe 50% solids kind of density. So substantially less water, substantially less volume that you're sending out to the pond.
And so again, you're saving on the amount of space you need to use if you even if you're still using a tradition or a pond system of some description. You also mentioned a little bit about water recovery as well. There, about one, less chance of evaporation, and two, you're able to recirculate the water back into the system pretty much straight away. What have you any idea off the top of your head typically what kind of water volume you'd be recirculating into a typical aggregate system?
So if you're using just a thickener, no filter press, you're typically looking at recovering, say, 85, 90% of the water with just the thickener. So then the amount of water that you need to re-add back into the process, say might be 10 to 15% of the water that you're needing to use to wash the material. So it's a big reduction in water versus not using
Yeah,
thickener.
well, there's obviously parts of the world where water is a very precious commodity, so you can see how that would be a massive benefit, being able to recirculate such a significant volume of the water. You also mentioned there a couple of times, Corey, about a filter press. So the other option would be to pump that slurry or treat that slurry further using the likes of a filter press. Again, for the benefit of everyone listening, do you want to give us a brief description of what a filter press is and how it works?
So, how a filter press works is it's basically composed of a bunch of plates. Each of these plates is recessed on each side so that when you put two plates together, it forms a cavity. So, if you have a 200 plate press, you would have 199 chambers formed or cavities. Each of those plates is lined with a filter cloth so that when you close all those plates, and you hold that closed, you're able to pump all those chambers full of solids. And as the slurry comes in, the solids can't get out through the filter cloth, so they stay trapped in that chamber. You end up keeping the pump on until you've packed each of those chambers full of solids. So, unlike what most people think, where they think it's an accordion squeezing and creating the cakes, it's actually closed first, and then you pump it full of solids.
So when they discharge, they're still relatively wet. They're dry. What sort of what state are those filter cakes in whenever you discharge them?
Yeah, so when you feed into the filter press, you're looking at say 30 to 50% solids, generally speaking, in these type of applications, and you then are able to dewater that into a cake that would be say 70% to 85% solids. The range of the density is really driven by the surface area of the particles. The smaller the particles are, the more surface area they have. You'll have a perfectly dry looking cake that's 70% solids. And if you have a coarser solids, maybe it's manufactured fines from washing, crusher dust, you might have a cake that's 85% solids. Both can look like a very dry cake. Um, and to the eye would look like, the same. Cooking it, you can see there's always going to be more water if you have a finer size
Yeah.
gradation. Um,
But ultimately, you can come in with a loading shovel, pick it up, and take it away
yeah,
to
yeah, you're
dispose
going
of
to be
it.
able to grab it with a loader. You're going to be able to convey it into a pile. It's going to be a drip free cake that you can hopefully try and find a beneficial use for,
Yeah.
or use in reclamation of the quarry or mine to backfill areas that you're done mining.
Okay. And again, there's you quoted some numbers there. You talked about material typically leaving a thickener 30 to 50% solids, and material leaving a thick filter press at 70 to 85% solids. Again, to me, there's a significant um, value add there in terms of the amount of water that's coming back into your system. So again, is there any way to quantify that in rough terms, Corey?
Yeah, I mean, in rough terms, let's say that if with just the thickener, you're 85 to 90% recovery of the total processed water. With the filter press, you're probably more towards 90, 95%. And again, it'll come down to what products are you creating. Where you lose water in a completely closed loop process is each of the products, whether it be sand, aggregate, or whatever you're mining, will have some amount of moisture that you lose with that. So why don't you get to 100%? Well,
Right.
you always have some water in each of those products. So say the filtered cake has 15% moisture, 20% moisture. The sand products might have 10, 12,
Yeah.
15% moisture.
Yeah. But that's of that fraction. So 15% of your filter cake is 15% of your tailings, if you like, not 15% of the overall.
Yep, no, exactly. So when you add it all up and you look at the comprehensive, mass balance, you're only having to add in back, say, 5% of the total volume of water that you're recirculating. So huge savings in water versus any of the other dewatering technologies that are out there.
So again, is there any other um, is there any downside to a filter press?
So I would say that the biggest downside of the filter press or the thickener is going to be if you put in too small of a thickener filter press in the beginning, which is why based on the hundreds of projects we worked on, or based on testing, if testing is available, you want to look at, just like any piece in the plant, making sure that you don't create a bottleneck. So if you're not able to process the tailings, then you're going to limit the processing capabilities of the plant, and that's definitely not something that you want to do. So upfront testing is going to help you to prevent that.
Yeah, so it's really the key to basically do your homework up front, understand the material that you want to process, how much of it you want to process, and understand its characteristics. Is that and then throughout the process, is there anything else you can do to kind of optimize that? You mentioned earlier on about different kinds of sensors and different pieces of technology that can be used.
Yeah. So going back to the thickener, you're dosing a polymer. There are sensors and options for automatically adjusting the amount of polymer to ensure that you're not over flocking or overdosing, or that let's say that the plant is continuing to run, but the person feeding the plant stops putting solids into the feeder for 10 minutes. You don't want to just keep dosing chemical if there's no solids coming in. So introducing sensors to measure what's happening, say in the feed well, what flocculation is happening, can make a big difference in just keeping the right amount of chemical in the settling. Then as the material settles, a lot of the thickeners that you see out there don't have a lot of knowledge, the operators, on what density are they pulling out of the thickener. There's some great options available for measuring that. We like to put pressure sensors on the sides of the tank where we can basically measure the weight or the density of everything that's above that sensor. So if we introduce one or more sensors, we can give a good idea of when we have the right density to then take to the filter press. And if you're able to optimize that, just like anything else in your processing plant, the better you can optimize the feed for the next process, gives you a knock-on effect of efficiency. So, in the thickener, most thickeners, you'll be able to measure the rake torque. If there's rakes in the thickener, what kind of torque is being generated. That's not always as accurate as also being able to measure, say, the density of what's in the thickener. So we like to, where possible, include multiple sensors to give the operators a better idea of what's actually happening in the tank and when is the right time to send that over to the filter press. So let's say that you start pumping the mud over to the filter press at 25% solids. The cycle time may be 2 or 3 times longer than if you were to send it over at 40% solids. So in the upfront testing and design of the thickener, going back to what we talked about with residence time, if you can get the thickener designed for the ideal residence time, in addition to enough area, cross-sectional area for the right rise rate, then you're setting yourself up for success in reducing the cost of the filter press. And, generally speaking, it's a lot cheaper or less expensive to put extra money in the thickener than to have to oversize the filter press to compensate for a bad thickener design or a bad process, inadequate sensors, in the process that's feeding the filter press.
Yeah, it goes back to what you said before about just, preparation. Preparation is key. Prepare your material, prepare yourself, do your homework, test the material, and understand what's happening with that material at each stage in the process. Preparations is key to you know the whole process, in terms of being able to size everything, being able to understand how one piece of equipment's going to work, with the next one following on. So, and again, understanding the material characteristics. Yeah. So
Yeah, no, I mean, I think it's the physics is something that you can't fight. So you have to know what's the reasonable range of how fast I can settle these solids in the thickener. How much chemical is that going to take? If I do a bigger tank, how much can I save on chemical? If I give more time in the thickener, so more storage time, more residence time, how much can that reduce the size of the filter press or just the amount of hours that I'm running the filter press? Those are a lot of the key considerations in the thickener. Going to the filter press, then you have similar considerations of what are you able to measure? Are you able to measure the flow rate with, say, a flow meter? So you can accurately see, the filtration curve and determine a stop point for the end of the cycle. How big of a surge tank are you putting in? So when you design the system, if you do a bigger thickener and you store the material longer in the thickener, you're continuing to improve the density and the downstream processing capabilities. If your goal is, my thickener's in, but I'm going to put in a massive buffer tank or surge tank, that's good for being able to run the filter press more hours than the thickener, but it's no longer conditioning the feed. All it's doing is mixing it and storing it. So
Just keeps it homogeneous, essentially.
yeah, so in the end, if you're starting from scratch on your tailings plant, it's better to put a little more money into the thickener, be able to store more material in the thickener where it's continuing to do some of the work by gravity for you, and then use the surge tank just to have, say, a couple cycles worth of material in that surge tank.
Yeah, well, I know there was a plant that we put into the UK recently, and we did an extra meter height on the thickener, and I believe the density of the underflow coming out of that was a good bit higher than it would have been otherwise. And again, that goes back to what you talked about with preparation. It was basically preparing the material to then go to the filter press. And again, I know that from being on site that they're getting a really really good consistent dry cake from that installation as well.
Like you're saying, David, they're adding an extra meter of height to the thickener. Just creates extra time that you can store material in the thickener. Let gravity do the work for you. There's been a lot of sites that we've done upfront testing work and design to optimize the thickener in order to save money on the number or size of the filter presses. So, like, we replaced some belt presses in California on a job that if we didn't do the upfront testing and processing, everybody was quoting them 2 filter presses. By optimizing how they were processing the material in their plant and what they were doing to condition the material, we were able to end up with just 1 filter press to replace multiple belt presses and save them a lot of money. Another site that I can think of offhand, basically by doing a deep cone style thickener, getting a lot of head pressure, as well as introducing some pickets into the material, we were able to keep them into 1 filter press instead of 2 on a very tight space. So, really, if the thickener's already there, there's not much you can do. But if we can start the process from scratch, we can create some substantial savings in the total process just by conditioning the feed better.
All right. Well, I'm kind of conscious of time here, Corey. I think we're kind of coming to the end of our podcast. So if I just want to recap on what we've talked about today, we talked about tailings and how tailings were traditionally managed, which is in significantly large tailings ponds or dams, if so to speak. We've kind of evolved past that in a lot of new sites into using the likes of a thickener, which is obviously helps, well, 1 with health and safety, 2 water recovery, and 3 probably planning. And then to take that a step further, you're going to further treat that with a filter press, which is going to again, save on space, recover more water. Again, basically making your a more efficient operation. I suppose we get just a word or two about McClanahan in terms of what we have to offer. Corey, is it is something you want to add about that before we wrap up?
Yeah, I mean, the exciting thing for us as we're looking at these kind of projects is we've got a lot of different tools. So when we look at the thickeners, for example, we have several styles of thickeners that we can deploy to give you the best conditioning of the feed, most cost reduction in the chemicals and the OpEx, fitting into a tight site footprint. On the filter press side, we own a company called Diefenbach that's been building filter presses since 1907. So we have a very long history of filter presses that we bring to the table, with all of McClanahan's development in tailings with our own filter press, and then acquiring Diefenbach a couple years ago, taking the best of both worlds, combining that into our 3rd generation filter press. We've got a lot of different ways to slice and dice it. We didn't really get into this in great detail in the podcast, but we also have things that we look at to reduce the amount of material coming to the tailings. So if we can create a a sand product that's say 60 micron by 38 micron, and that's a cheaper way to process that portion of the material than using the thickener and the filter press. We have all of those different tools that we can look at. So, we like to look at it comprehensively. And, if you take a look on our website at, the amount of different types of process equipment that we make, we really do have the most versatile ability to tackle your unique challenges with the right piece of equipment. I think in your part of the world, they call it horses for courses.
Horses for courses, yeah.
You want the quarter horse for that race, and a different horse for another race.
Yeah.
So that's the great thing working at McClanahan is we have a lot of testing capabilities, and we have a lot of tools that we can then apply to that data to give you the most efficient process, whether it's tailings or whether we're talking about the actual processing of the aggregates or C&D material.
All right. Well, Corey, thank you very much for joining me today. For those who've joined to listen, thank you for listening to Groundwork, a McClanahan podcast. Be sure to subscribe on your favorite listening app for new episodes, and follow McClanahan on social media for more content. Thanks. Bye-bye.
Thanks.